All right, so what we're going to do is we're going to go over that formative that you took on Friday on limiting and excess reactants. So if you want to take a look at your formative, just see what you did, see how we can change things. The first thing I do want to mention is that I thought I changed it on here, but apparently I did not. This should just be H2S because in the reaction we only use an H2S, not an H2S3. So your answers might look a little bit different. I know a lot of you are getting about 98.2 or 98.2 something for your molar mass of H2S3, and that's totally fine. My mistake, not yours. So what we're going to do is first we're going to balance our equation. And if we look, I'm just going to go by what we have, and we can see that we have 2 aluminums on our product side, which means we need 2 aluminums on our reactant side. If we look, we have 3 S's or 3 sulfurs on our product side, so we need 3 sulfurs on our reactant side. And that means we have 2 aluminums on each side, we have 3 sulfurs on each side, and then we have to make sure our hydrogens match, and we have 6 on our reactant side, which means we need 6 on our product side, so we got to multiply over here by 3 to make our balanced equation. Now that we have our balanced equation, we can start to set up our problem. So I'm not going to go through the whole steps each time, but we'll do it once. So we're going to start with just this one right here. We're going to start with our 76.75 grams of H2S. Remember, I told you I made the mistake, not you guys. So just don't worry too much. But we're going to start with our grams of H2S. And instead of going straight to grams of aluminum sulfide, we are going to take our steps. So we can't go straight to grams of another compound. We can go from grams to moles of that same compound using the molar mass. Right in there, molar mass. Getting to moles, now our next step is to go from moles. We have 2 options. We can go to grams of that same compound, which is where we just came from, so we don't want to do that. So we can go to moles of a different compound. And what compound do we want to go to? The one that we're trying to figure out how much we're going to produce. So we're trying to get to moles of Al2S3. So we're going to go from moles to moles of Al2S3. And we're going to use our mole ratio to do that. Once we're in moles of aluminum sulfide, we can go from moles to grams of that same compound, which is what we want to end up with. So we're going to go to grams of Al2S3, and we're going to use our molar mass again, this time the molar mass of aluminum sulfide. Now that we have all that, what we can do is we can set up our problem. So we're going to set up our railroad tracks. We're going to put in our 76.75 grams of H2S. We want to use the molar mass of H2S to go from grams to moles of H2S. Our molar mass is going to be the number of grams that equals how many moles? It always equals 1 mole. So it's always for every 1 mole of H2S. And we get our molar mass from our periodic table. So that means we have to look at our periodic table. And you should find out that the molar mass is 34.08 grams of H2S. That's equal to 1 mole. Now that we're into moles of H2S, we need to go from moles of H2S to moles of aluminum sulfide using the mole ratio. Where do you get the mole ratio from again? That's right, you get the mole ratio from the balanced equation. So we're going to look at our balanced equation. We know that 3 moles of H2S is needed to make 1 mole of aluminum sulfide. So we have 3 moles of H2S goes on the bottom. That way those moles cancel. And the 1 mole of Al2 S3 goes on top. And then our last step is just to do our molar mass again, but this time the molar mass of what compound? That's right, we're doing it the molar mass of aluminum sulfide this time. So the 1 mole for our molar mass is going to go on the bottom this time because we want those to cancel. And on top, we're going to put our molar mass of 150.14 grams of aluminum sulfide. Now, when we do this, we're going to multiply everything on top together, multiply everything on bottom together, and then when we divide those two, you should get an answer of 112.71 grams of aluminum sulfide. So that's your first equation. That's your first problem. Now we have to do it again because this is a limiting reactant problem. I've given you 2 different sets of grams. So we have to do it a second time, but this time we're going to use, I'm going to use a different color here. We're going to use the 56.78 grams of aluminum. And we're going to use the same setup. Instead of grams of H2S, we're going to replace that H2S with aluminum, and we're going to do the same thing over again. So we're going to draw out our railroad tracks. And we're going to put our 56.78 grams of aluminum on the top. We're going to use our molar mass to get from grams of aluminum to moles of aluminum. So remember, the molar mass is always from the periodic table, and it's always equal to 1 mole. So 1 mole of aluminum is 26.98 grams of aluminum. Now that we have our 1 mole of aluminum, those grams of aluminum have canceled. They're gone. We're in moles of aluminum. Now we can go from moles of aluminum to moles of aluminum sulfide. So we have to use our balanced equation again. We need 2 moles of aluminum to make, that's right, 1 mole of aluminum sulfide. So we put the 2 moles of aluminum on the bottom because we want those moles of aluminum to cancel. And then we put the 1 mole of aluminum sulfide on the top. All right, our last step again is the same step as before. It's the exact same molar mass as before, so we can just copy and paste. We know that for every 1 mole of aluminum sulfide, we're going to need 150.14 grams of aluminum sulfide. That way our moles of aluminum sulfide have canceled. We're left with just units of grams of aluminum sulfide, and we can solve this problem to get our answer here of 157.99 grams of aluminum sulfide. Now, we got 2 different answers. Now we have to determine what our actual answer is going to be. So if we look at our problem, it says that we're trying to figure out how many grams we're going to produce. Now, if I just told you about the H2S, but I just told you about that many grams, we would know we made 112.17 grams. And then if we ignored all the aluminum, just knew that aluminum existed. Now, if we do the opposite, if we ignore all the H2S and we just look at our aluminum, we know we would make 157.99 grams. Now, if we look at both of them together, the limiting reactant is the one that's going to be produced or the one that we're actually going to make. Because once the limiting reactant runs out, we run out of that reactant. There's none of it left. It's all gone. Once it's all gone, there's no more reaction. So which one's going to be our limiting reactant? This one right here. Limiting reactant. And it's our limiting reactant because it runs out first. So how many grams of aluminum sulfide are we going to produce? We're only going to make this 112. We're only going to make this right here because once this is done, we've run out of aluminum sulfide. We have no more left to produce. We can't make any more after that. So that is our answer right here. So this one is kind of just done to make sure that it's not the answer. So we have to double check our work. So now we're going to do it a second time. We're going to look at this problem. So it says how many grams of lithium nitrate is made from 5.78 grams of lithium sulfate and 4.89 grams of calcium nitrate. Make sure to circle that limiting reactant. So it wants you to circle that answer. So the first thing we gotta do every time is to balance our equation. I'm not gonna go through it, but this is our balanced equation with a 2 right there, making sure that we have 2 lithiums and 2 sets of nitrate to balance out that reaction. Now, if we set up our first limiting reactant problem, we're going to do it with the 5.78 grams of lithium sulfate. There we go. All right, and we're going to do the same setup as before, so I'm not going to go through it again, but we know we're trying to go from grams to grams, which means we first need to use our molar mass to get to moles, because the only way to convert between 2 different compounds is to get to the moles and convert using the mole ratio. No other conversion will work. So if we want to get to our mole ratio, we have to find the molar mass. We know the molar mass is always equal to 1 mole of that compound. So if we use our periodic table to find that molar mass, we'll find out that it's 109.94 grams of lithium sulfate is equal to that 1 mole of lithium sulfate. That means those grams of lithium sulfate have canceled because we have them on top and then on the bottom, and now we're in moles of lithium sulfate. We want to get to lithium nitrate at the end, so we want to use the molar ratio to go from moles of lithium sulfate to moles of lithium nitrate. If we look at our balanced equation, we have 1 mole of lithium sulfate is needed to make this reaction happen, and we'll make 2 moles of lithium nitrate during this reaction. So it's 1 mole of lithium sulfate on the bottom, because we want those moles of lithium sulfate to cancel, and we put our 2 moles of lithium nitrate on the top. And now we're going to do our last and final step, is to get from moles to grams of lithium nitrate using the mole ratio. Not mole ratio, oh my goodness, the molar mass. Perfect. So if we find our molar mass, it's always equal to how many moles? That's right. I started writing it even before you said it because I knew you would get it right. It's 1 mole of lithium nitrate. And that 1 mole of lithium nitrate is equal to 68.95 grams of lithium nitrate. Now we take our top and we multiply them all together and we divide it by the bottom. We should get an answer up just about 7.25 grams of lithium nitrate. Now, that's not our only problem because we want to find that limiting reactant. So we have to do it a second time. So if we do it a second time, we're going to set up the same problem, same railroad tracks, but this time we're going to use that 4.89 grams of calcium nitrate. First thing we have to do is to get rid of grams of calcium nitrate, and the only thing we can convert grams to is moles of the same compound. So we go with 1 mole for our molar mass of calcium nitrate is equal to 164.1 grams of calcium nitrate. Those grams of calcium nitrate have been canceled, and now we're in moles of calcium nitrate. If we convert from moles of calcium nitrate, we can either go from moles to grams, but we just did that, so we don't want to do that again. So we can go from moles of one compound to moles of another. And we're trying to find out the grams of lithium nitrate, so we want to go from moles of calcium nitrate to moles of lithium nitrate using our balanced equation. 1 mole of calcium nitrate is going to be equal to 2 moles of lithium nitrate. So we're going to put that in here. So our 1 mole of calcium nitrate is going to go on the bottom. And that's equal to those 2 moles of lithium nitrate, because we want those moles of calcium nitrate to cancel out. Now our last step is just to do that same molar mass from before using the 1 mole of lithium nitrate on the bottom and the 68.95 grams of lithium nitrate on top. When we multiply the top together and multiply the bottom together and divide them, we're going to get an answer of 4.11 grams of lithium nitrate. So now can you tell me which one is our answer, the 4.11 or the 7.25? It is going to be the 4.11 grams of lithium nitrate because it's going to run out first and then we'll be done. So which one is our limiting reactant? Is it the lithium sulfate or the calcium nitrate? That's right. Our lithium sulfate is our limiting reactant. Nice work, ladies and gentlemen.